Let's talk about the elements. Okay, so we have a lot of elements that we know about these days. In the background, you can see kind of a fraction of the periodic table over there. This little bubble here cuts off a little bit of the periodic table I have posted in my home office here. So Dalton, he's a really important guy to the discovery of a lot of the things that we know about elements in the periodic table. But he lived a long time ago. Things were different. When he was going through and doing all of his discoveries, you can see that his symbols were a little bit different. We have much different symbols today, so it's a little bit harder to follow crazy symbols like this. I am really glad that I don't have to be drawing, you know, a chemical symbol that looks like that. That would get kind of confusing. Or like, oh, let's do, you know, 2 lines versus 3 lines. So a little bit different back then. Now, one thing though about Dalton symbols is here they are colorized. Obviously, when Dalton was doing his work, it was a long time ago, didn't have color printers, so wasn't like he could colorize things, but we've started colorizing things. So some of the stuff that you see here, you'll actually start seeing more of as you learn more chemistry. When we use little dot symbols, or when we use little like ball and stick models and stuff to represent things, we actually do use some of these same colors for some of these elements. In fact, I can pull out this model kit right here. And when I use these little red pieces, those are representing oxygen. Green is typically representing chlorine. It's gray on here, but we usually use white for hydrogen, black for carbon, blue for nitrogen. Sometimes we have to substitute other colors here and there. Purple, we can use purple for sodium or for iodine. So we actually do use some of these colors still when we have other representations. So today our elements and symbols are a little bit different. So our symbols are usually 1 or 2 letters. There are some cases where we are still working on the official discovery of an element, and I put discovery in air quotes because anything that gets added to the periodic table now isn't anything that we've discovered naturally. It's something that we have created in a particle accelerator. So it's all artificially done. So those get placeholders usually with a U. There might be a capital U, a lowercase u, and then another letter that are placeholders there. So when we have a single letter symbol, it is capitalized. When we have a double letter symbol, the first letter is capitalized, and then the second letter is lowercase. So something like hydrogen, single letter symbol, it would just be H for hydrogen. Something like sodium, which its symbol is Na, we would use capital N, a lowercase a. Okay. So there are a lot of elements that have a really easy way to follow. Symbol follows the name that we currently use for it. So xenon, Xe, bromine, Br, etc. Now, there are some holdovers though from when everything was done in Latin. So I just used sodium as an example on the previous slide. Sodium, the symbol for sodium is Na. Sodium does not start with Na. So why do we use Na for sodium? Well, it's a holdover from these early names here. So sodium, right here, what we know it as today, was known as natrium. That's where the Na comes from. So antimony, copper, gold, iron, lead, mercury, potassium, silver, sodium, tin, tungsten, all of those, we still use a symbol that's been derived from its former or Latin name. So these are things you need to start getting to know now. All right, don't wait till we get to the chapter on nomenclature. You are now responsible for being able to give me the symbols for various different elements, or give me the names from the symbol for various different elements. All right, you need to know these. This might be a thing where you just have to rote memorize them. Yes, we do need to memorize things in life. We need to have certain things at recall. So whenever I was doing anything nomenclature, or if I was taking a language class, I used to make flashcards. I used to put them on a little ring and keep in my pocket. We didn't have cell phones with all the crazy apps and stuff that we have now when I was going through school. So I used to throw those flashcards in my pocket. And if I had to go to the grocery store and I was stuck in line for 5 minutes, I'd pull out my flashcards and I'd start working on things that I had to memorize. So start memorizing these. Okay. So what I'm going to expect that you're responsible for are the first 36 elements and then several others after that. Okay. So I don't expect you to know the entirety of the whole periodic table, but I do expect you to know a good portion of it. Okay. I'm not asking you to memorize like the atomic number or the masses or anything like that. You will be allowed to use a periodic table when you take exams, but you do need to know what the symbol and what the name are. All right, because I will be providing you with a document that has the periodic table that you are allowed to use for exams. It's not going to have the names on it, just the symbols. Okay. So just some interesting stuff about the elements. We have different compositions. So our galaxies, a huge portion of the galaxy is all hydrogen. There's a bunch of helium, and then all the other elements actually only make up 0.25% of the known galaxy. When we look at Earth, Earth has a ton of oxygen, and then we've got bunch of silicon, aluminum is really prevalent, calcium, sodium, so there's a lot of distribution. But a ton of elements fall under this all other elements 1.1%. So a good portion of the elements that we have are actually only really present on this planet in trace amounts, which is part of why we have to be really conscientious not to waste the resources that we have. Okay. When we think about ourselves, human beings, a human being by mass is made up of about 65% oxygen, 18% carbon, 10% hydrogen. Nitrogen, calcium, phosphorus are all there in appreciable amounts, and all the other elements that make up our bodies and make sure that we are functioning correctly are also there in trace amounts. Okay. And then we can start thinking about the periodic table, and we will start discussing the periodic table. This is just kind of interesting because I have it color coded based on when things were discovered. You don't have to memorize dates of when things were discovered. It's just interesting to look at kind of as we developed our understanding of science, how it all evolved and when we knew what. So again, so all these things here that are marked 1950 to 1999, a lot of that stuff is where we started smashing things together in particle accelerators. So a lot of elements like berkelium and californium, einsteinium, those are not natural elements. They were created in a particle accelerator. If you're the one that does that work, you get to name that new element. So yeah, surprise, surprise, berkelium was done at the particle accelerator at the University of California, Berkeley. Hence berkelium. Californium, also done at the University of California. So that's where some of those come from.